we want to note three important theorems in this chapter and which is mutually related. The first one is the perpendicular bisector of any chord of a circle passes through its center. And that, what is a chord? The chord is a line joining any 2 points on a circle. സർക്കിളിൽ ഉള്ള 2 പോയിന്റ് ജോയിൻ ചെയ്യുന്ന ലൈനിനെയാണ് നമ്മൾ കോഡ് എന്ന് പറയുന്നത്. ദിസ് ഈസ് എ കോഡ് ആൻഡ് ദിസ് ഈസ് അനദർ കോഡ് ഹിയർ. യു ക്യാൻ സീ 2 കോഡ്സ് ഹിയർ. ഫസ്റ്റ് വൺ ഈസ് ദിസ് ആൻഡ് സെക്കൻഡ് വൺ ഈസ് ദിസ്. ആൻഡ് വാട്ട് ഹിയർ ദ തിയറം സേസ് the perpendicular bisector of any chord. Therefore, you can see the perpendicular bisector of this chord. Not only perpendicular, but also perpendicular bisector, which is this passes through the midpoint of the chord. And this angle make 90 degree. That is why this is called a perpendicular bisector. And if it is a perpendicular bisector, it sure passes through the center of the circle. That is the first theorem you want to study. And here another chord you can see, and the perpendicular bisector is also here, and this perpendicular bisector is for this chord. Therefore, this perpendicular bisector is also passes through the center of the circle. And this theorem is also otherwise we can see in another statement. That is, we can say the line joining center of the circle and the midpoint of the chord is always perpendicular to the chord. We can say otherwise, the line joining the center of the chord and center of the circle is always perpendicular to the chord. This makes what? 90 degree. And otherwise we can see the third statement. We can see what? The line perpendicular which is from the center of the circle to a chord bisect the chord. We can see this theorem in other ways. That is, we have 3 statements here. First one is the perpendicular bisector of any chord passes through the center. And second one is the line joining the center and the center of the chord will be the perpendicular to the chord. And otherwise the third one says what? The line from center, the perpendicular line from center to any chord bisect the chord. That theorems we want to use in this chapter. Prove that the line joining the centers of 2 intersecting circles. You can see 2 intersecting, one big and one small here, and that is intersecting in these 2 points. Prove that the line joining the centers of 2 intersecting circle. The line joining centers means this line is specified here. The line joining centers of 2 intersecting circle. Therefore, this line is here specified. This is the line now specified. Is the perpendicular bisector of the line joining the point of intersection. And this is the perpendicular bisector to the line joining the point of intersection. Point of intersection means these 2 points of intersection. And the line joining means this is a second specified line. And we want to prove what? These 2 lines are perpendiculars. These 2 lines are perpendiculars. Therefore, how we prove that? And now we consider this line. This is the radius and also this line. This is also the radius. And this is the radius of second circle. And you can complete this figure. Then you can see this is a side of this big triangle, and this is also a side of this big triangle. And you can see these 2 sides are equal. We can name it is A, B, C, D. Then what happened here? AB is equal to what? AD. Two triangle we consider. The upper triangle and the lower triangle. This AB and this AD are equal. What is the reason? That is radius. Radius of same circle. And same procedure we can say BC is equal to CD. That is BC is equal to CD. What is the reason? That is also radius of next circle. Second circle radius. They are equal. And AC is same as AC. You can see AC of this triangle is same as AC of this triangle. Upper triangle AC, lower triangle side equal. Because they are common sides. AC and then common side. Therefore, by SSS criteria, yes criteria, we can see triangle ABC. Triangle ABC is equal to what? Triangle ADC. ADC എന്ന ട്രയാങ്കിളുമായിട്ട് ഈക്വൽ ആണ് എന്ന് പ്രൂവ് ചെയ്യാം. Therefore, we can see this angle is same as this angle. Angle BCA. We can see angle BCA is equal to, this angle is BCA is equal to angle DCA. Angle DCA. We have this upper triangle and lower triangle are equal. Therefore, this angle is same as this angle. That is angle BCA is same as angle DCA. Now we consider these two small triangle. Now we consider these two small triangle and we put a point P. The name intersection is P here. And what happened? BC is equal to CD. Now we can say BC is equal to CD. BC is equal to CD. What is the reason? Radius, same circle radius. And what next? BCP, angle BCP is equal to DCP. Angle DCP. How we get that? That is, we already proved here. These two angles are equal. And now BCP and DCP are equal. Now what happened? CP is equal to CP. CP is equal to what? CP. What is the reason? CP is common to both upper and lower triangle. Therefore, we can see these two triangles are equal. These two triangles are equal. Which triangle? The small triangle BCP is equal to small triangle DCP. So, small triangle DCP you can see. Now, we have these two triangles are equal. Therefore, these two angles are equal. These two angles are equal. Angle BPC, we can say angle BPC is equal to angle DPC. Angle DPC. What is the sum of this angle? What is the sum of this angle? But the sum is equal to what? 180. This sum is 180 and they are equal. Sum is 180 and they are equal. What happened? Each angle BPC and DPC is equal to 90 degree. ഇതിൻ്റെ sum 180 ആണ് and these two angles are equal. Then only one possibility, thus each angle should be 90 degree. Therefore, we can see AC. This angle is 90 degree means AC and BD are perpendicular. AC is perpendicular to, you can see AC is perpendicular to BD. The picture on the right shows two circles centered on the same point. Two circles, you can say inner circle and outer circle, but they have same center. The question says they have same center on same point and the line intersecting them. A line is intersecting them. Prove that the points of the line between the circles on either sides are equal. Prove that the parts of the line between the circle means what? Part between the circle. This is between the circle and this part is also between the circle. If we want to say these two parts are equal, we want to prove that. How we prove that? We want to prove or we want to construct a perpendicular to here. Then we can name it as AB and we can name this part is CD. And we want to prove what? AC is equal to BD. Then by this construction as a perpendicular, we want to draw this as perpendicular to here. What we can say? This point is O. then we can say AB is a chord. AB is a chord of the large circle. Therefore, we can say AO is equal to OB. We can say AO is equal to OB. What is the reason? We have the line joining the perpendicular from the center to a chord bisect the chord. Therefore, AO is equal to BO. Therefore, also same relation, that is CD. The same argument. CD is the chord of the inner circle and the same perpendicular and center to a perpendicular. Then what happened? It bisects CO also. CO is equal to what? OD. CO is equal to OD. Then we have AO is equal to OB and AO minus CO, same, AO minus CO is equal to what? OB minus OD. AO same, OB same, CO same, OD same. Therefore, this relation is also same. Then AO minus CO is equal to what? Simple AC. This length is AC. And OB minus OD. OB minus OD, what? DB. That is AC is equal to DB. That is, the parts of the line between the circle are also equal. The figure shows two chords drawn on either sides of a diameter. You can see a diameter here and two chords here. What is the length of the other chord? And first chord, one chord, you can give the distance is 3 centimeter, length is 3 centimeter. It's shown the length is 3 centimeter. And two angles are given here, also 30 degree and here also 30 degree. We want to find, this chord is 3 centimeter. You want to find what is the length of this chord. From, this is a center. And you can draw a perpendicular to this. You can draw a perpendicular to this. That is a perpendicular. You can draw a perpendicular. And you can see a perpendicular to this chord also. Then what happened? Consider these two small triangles. What happened? This side is a common side. It is okay. This side is a common side. That is, from this point to this point, this line is a common side to both these two triangles. And this angle and this angle are same. These two angles are same. Each one is 30 degree, 30 degree. And this angle is 90 degree. This angle is 90 degree. Therefore, you can see two angles are same. Two angles are same. If two angles are same, automatically the third angle will be same. Third angle will be same. And three angles are same. And one angle are same. Three angle equal ആണ്. One angle equal ആണ്. അപ്പോൾ നമുക്ക് വേണമെങ്കിൽ ആ ഒരു ക്രൈറ്റീരിയയിൽ വെച്ചിട്ട് നമുക്ക് ഈ രണ്ട് ട്രയാങ്കിളും ഈക്വൽ എന്ന് പറയാം. നമുക്ക് SAA ക്രൈറ്റീരിയ ഉണ്ട്. SAA ക്രൈറ്റീരിയ ഓർ ASA, രണ്ട് ആംഗിളും ഇൻക്ലൂഡഡ് സൈഡും. അപ്പോൾ നമുക്കിവിടെ രണ്ട് ആംഗിൾ ഉണ്ട്, അതിൻ്റെ ഇൻക്ലൂഡഡ് സൈഡും ഉണ്ട്. അത് നമുക്ക് ഒരു സൈഡും രണ്ട് ആംഗിളും ഇൻക്ലൂഡ് ആയാലും നമുക്ക് ഇങ്ങനെ പറയാം. SAA എന്നുള്ള ക്രൈറ്റീരിയ ഉപയോഗിച്ചുകൊണ്ട് നമുക്ക് ഈ ടു ട്രയാങ്കിൾസ് ആർ ഈക്വൽ എന്ന് പറയാം. ഈ രണ്ട് ട്രയാങ്കിൾ ഈക്വൽ ആയി കഴിഞ്ഞാൽ എന്താ പ്രത്യേകത? ഈ സൈഡും ഈ സൈഡും ഈക്വൽ ആയിരിക്കും. അതായത് ഈ സൈഡ് എത്രയാണ്? ഇപ്പോൾ ഇത് ഹാഫാണ്. ഹാഫ് ആകുമ്പോൾ 3/2 ആണ്. ഇത് 3/2 ആണ് ഈ സൈഡിൻ്റെ ലെങ്ത്ത്. ദർഫോർ ഈ സൈഡും എന്തായിരിക്കും? 3/2 ആയിരിക്കും. ഇത് 3/2, ഇത് 3/2 ആണെങ്കിൽ ഫുൾ സൈഡ് എന്തായിരിക്കും? ഈ മൊത്തം ലൈൻ എന്ന് പറയുന്നത് 3 സെൻറ്റിമീറ്റർ തന്നെ ആയിരിക്കും. A chord and a diameter through one of its end are drawn in a circle. You can see a chord here and one of its ends, a diameter is drawn. One of its ends, you can see a diameter is drawn. A chord of the same inclination is drawn on the other side of the diameter. You can see there is same inclination. For this inclination and this inclination, we draw another chord here with the same inclination. That inclination means the angle is same here. This angle, if x, you can see this angle is also x. And we want to prove the chords are same length. You want to prove the chords are same length. അപ്പോൾ ഈ പ്രോബ്ലം തന്നെ നമ്മൾ നേരത്തെ ചെയ്ത് അതിൽ നിന്ന് ഇതിലേക്കൊരു മാറ്റമൊന്നുമില്ല. അവിടെ ആംഗിൾ സ്പെസിഫൈഡ് ആണെന്ന് പറഞ്ഞിരുന്നു. നേരത്തെ പ്രോബ്ലത്തിൽ ഇവിടെ ആംഗിൾ സ്പെസിഫൈഡ് 30 എന്നും ഈ കോഡ് സ്പെസിഫൈഡ് 3 സെൻറ്റിമീറ്റർ എന്ന് പറഞ്ഞിരുന്നു. അപ്പോൾ നമുക്ക് അപ്പുറത്തുനിന്ന് നമ്മൾ എന്ത് ചെയ്ത് ഈ ആംഗിൾ സ്പെസിഫൈഡ് പറഞ്ഞിരുന്നു. ഈക്വൽ എന്ന് പറഞ്ഞപ്പോൾ ഇത് ആംഗിൾ 30 എടുത്ത് നമ്മൾ ഈ പറഞ്ഞ് ഈ 3 തന്നെയാണ് ഈ 3 എന്നും പ്രൂവ് ചെയ്തു. സെയിം പ്രൂഫ് തന്നെയാണ് ഇവിടെ നമ്മൾ പറയുന്നത്. ദർ ഈസ് നോ എനി അതർ പ്രൂഫ്. ദിസ് എക്സ്, ദിസ് ലെങ്ത് ഈസ് എക്സ് ആൻഡ് ദിസ് ഡിസ്റ്റൻസ് ഡി. ഈ ലെങ്ത് ഡി ആണെങ്കിൽ വി വാണ്ട് ടു പ്രൂവ് ദിസ് ഈസ് എക്സ്, ബട്ട് യു വാണ്ട് ടു പ്രൂവ് ദിസ് ഈസ് ആൾസോ ഡി. എന്താ ചെയ്ത് നമ്മൾ ഈ പെർപെൻഡിക്കുലറിൽ നിന്ന് നമ്മൾ സെൻറ്ററിൽ നിന്ന് ഒരു പെർപെൻഡിക്കുലർ വരച്ചു, ഈ സെൻറ്ററിൽ നിന്ന് ഒരു പെർപെൻഡിക്കുലർ വരച്ചു. നെക്സ്റ്റ് നമ്മൾ എന്ത് പറഞ്ഞു? ദീസ് ടു ആംഗിൾസ് ആർ ഈക്വൽ, യെസ്, ആൻഡ് ദീസ് ടു ആംഗിൾസ് ആർ ഈക്വൽ, യെസ്. Therefore the remaining angles are equal, yes. Therefore all angles are equal, all angles are equal, and one side is common. Therefore we can see, yes, a criteria, these two triangles are equal. We can see these two triangles are equal. If these two triangles are equal, what happened? The total distance is d. This is d by 2. Perpendicular from the center bisect the chord. Therefore this is d by 2. Therefore this is also what? D by 2. Therefore total length is also what is the double of d by 2. Therefore this length is also d and this length is also d. Hence the proof. The figure shows two chords drawn on either sides of a diameter. You can see a diameter here and you can see a chord here. This is a chord here, the given chord, and you can see another chord here. What is the length of this chord? This is 3 centimeter, and what is this is 3 centimeter, and this angle is what? 40 degree. And what is the question here? How much the angle or the other chord makes the diameter? ഈ chord ഈ ഡയമീറ്ററുമായിട്ട് ഉണ്ടാക്കുന്ന ഈ ആംഗിൾ എത്രയായിരിക്കുന്ന ക്വസ്റ്റ്യൻ. സിമ്പിൾ ക്വസ്റ്റ്യൻ. ദിസ് ഈസ് ആൾസോ 40 ഡിഗ്രി. പക്ഷെ പ്രൂഫ് പറയുമ്പോൾ നമ്മൾ എന്ത് ചെയ്യണം? നമ്മൾ നേരത്തെ പറഞ്ഞൊക്കെ വീണ്ടും റിപ്പീറ്റ് ചെയ്യണം. പെർപെൻഡിക്കുലർ ഇവിടുന്ന് ഇവിടേക്ക് എന്ത് വരച്ചു? പെർപെൻഡിക്കുലർ വരച്ചു. ദെർഫോർ ദിസ് ലെങ്ത് ആൻഡ് ദിസ് ലെങ്ത് ആർ സെയിം അല്ലേ? ഇത് 1.5 3/2 ആണ്. ഇതും എന്താണ്? 3/2 ആണ്. പെർപെൻഡിക്കുലർ ബൈസെക്റ്റ് ചെയ്യും. ഇത് 3/2 ആണ്, ഇതും 3/2 ആണ്. ദെർഫോർ ദീസ് സൈഡ്സ് ആർ ഈക്വൽ. ആൻഡ് നെക്സ്റ്റ് what we can see, this is a common, this is a common side. And next we can see what? This angle is same 90 degree. This angle is also what? 90 degree. Therefore this is a right triangle. Right triangle hypotenuse same ആണ്. One ഷോർട്ട് സൈഡ്, ഒരു സ്മോൾ സൈഡ് സെയിം ആണ്. തീർച്ചയായിട്ടും ഒരു റൈറ്റ് ട്രയാങ്കിളിൽ ഹൈപ്പോട്ട്ന്യൂസും ഒരു സൈഡും ഈക്വൽ ആണെങ്കിൽ ദ തേർഡ് സൈഡ് ആൾസോ ഷുഡ് ബി ഈക്വൽ. പൈതഗോറിയൻ ട്രിപ്ലറ്റാണ് വരിക. പൈതഗോറിയൻ ട്രിപ്ലറ്റ്. ഇപ്പോൾ 3 4 5 നമുക്കറിയാം. 3 സ്ക്വയർ പ്ലസ് 4 സ്ക്വയർ ഇസ് ഈക്വൽ ടു 5 സ്ക്വയർ. 9 പ്ലസ് 16 ഈസ് പ്ലസ് 20 ദറ്റ് ഈസ് ഈക്വൽ 25. അപ്പോൾ 3ഉം 4ഉം വന്നാൽ, അല്ലെങ്കിൽ 5ഉം 4ഉം വന്നാൽ പിന്നെ 3ക്ക് മാത്രമേ ചാൻസ് ഉള്ളൂ. അതേപോലെ തന്നെയാണ് ഇവിടെ. ഇവിടെ വൺ സൈഡ് ഹൈപ്പോട്ട്ന്യൂസ് ആൻഡ് വൺ സ്മോൾ സൈഡ് ആർ ഈക്വൽ. ഇത് രണ്ടും കോമൺ ആയി വന്നിട്ടുണ്ട്. അപ്പോൾ തേർഡ് സൈഡ് എന്ത് ഇവിടെ വന്നാലും ആ സൈഡ് തന്നെ ഇവിടെ വരുള്ളൂ. ദെർഫോർ ആൾ 3 സൈഡ്സ് ആർ ഈക്വൽ. ദെർഫോർ ബൈ SSS ക്രൈറ്റീരിയ സൈഡ്സ് ആർ ഈക്വൽ. ദെർഫോർ these two triangles are equal. These two triangles are equal implies what? നമുക്കറിയാം ആംഗിൾ ഓപ്പോസിറ്റ് സെയിം സൈഡ് ഈസ് ഈക്വൽ. അപ്പോൾ ഇതിനെതിരെ 4, ഈ സെയിം സൈഡ്സിനെതിരെ 40 ഡിഗ്രി ആണെങ്കിൽ ഈ സെയിം സൈഡിനെതിരെ ഇവിടെ എന്തായിരിക്കും? ദറ്റ് ഈസ് ആൾസോ 40 ഡിഗ്രി. ആൻസറൊക്കെ നമുക്കറിയാം, പക്ഷെ പ്രൂഫ് നമ്മൾ കൃത്യമായിട്ട് എഴുതണം എന്ന് മാത്രം. പ്രൂവ് ദാറ്റ് the angle made by two equal chords drawn from a point. You can see two equal chords here. രണ്ട് ഈക്വൽ കോഡ്സ് ആണ് ഡ്രോൺ ഫ്രം പോയിന്റ്. ഈ പോയിന്റിൽ നിന്ന് വരച്ചിരിക്കുന്ന ടു ഈക്വൽ കോഡ്സ് ആർ ഹിയർ. പ്രൂവ് ദാറ്റ് ആംഗിൾ മെയ്ഡ് ബൈ ടു ഈക്വൽ കോഡ്സ് ഡ്രോൺ ഫ്രം എ പോയിന്റ് ഓൺ ദ സർക്കിൾ ഈസ് ബൈസെക്റ്റഡ് ബൈ ദ ഡയമീറ്റർ ത്രൂ ദാറ്റ് പോയിന്റ്. ഈ ബൈസെക്റ്റഡ് ബൈ ദ ഡയമീറ്റർ, ഈ ഡയമീറ്റർ തന്നെ ബൈസെക്റ്റ് ചെയ്യുന്ന പ്രൂവ് ചെയ്യേണ്ടത്. You can see two chords from same point and there is an angle here and that angle is bisected by this diameter. We want to prove that. സെയിം പ്രൂഫ് നേരത്തെ നമ്മൾ പറഞ്ഞ പ്രൂഫ് തന്നെയാണ്. നമ്മൾ സെയിം ലെങ്ത് ആണെന്ന് പറയുന്നു. Therefore this length is L. This length is L. You can see this length is also L. And from here you can see perpendicular to here. And here also a perpendicular. You can see a perpendicular. This is a perpendicular and this is perpendicular. Therefore 90 degree. And you can see this is the hypotenuse for this triangle and this is the hypotenuse for this triangle also. And the second small sides are equal. This second small sides are equal. Therefore the third small side is also equal. These three third side, you can see this is a Pythagorean triplet. Like 3, 4, 5 or 8, 6, 10. Therefore 3 and 4 makes the next side 5. 8 and 6 next side should be 10. Therefore these two sides are equal. Therefore third side is also equal for a right triangle. ഈ സൈഡും ഈക്വൽ ആണ്. ഈ സൈഡ് ഇതിനോട് തന്നെ ഈക്വൽ ആണ്. ഈ ട്രയാങ്കിളിൻ്റെ ഈ സൈഡ് ഇതിനോട് തന്നെ ഈക്വൽ ആണ്. Therefore third side എന്ന് പറയുന്നതും എന്തായിട്ട് മാറും? ഈക്വൽ ആയിട്ട് മാറും. Therefore SSS criteria, you can see these two triangles are equal. What happened if these two triangles are equal? If these two triangles are equal, surely these two angles are equal. These two angles are equal. What is if these two angles are equal? What happened? This diameter is a bisector of this angle. These two angles are equal implies what? This diameter is a bisector of this angle. That is the proof. Draw a square and a circle through all four vertices. Draw diameters parallel to the sides of the square. Draw a square. You can see a square here. The draw a square is over. You can see a square. Draw a square is over. And next what? And a circle through all four vertices. You can see the vertices of the square here. And now we complete a circle which passes through all the four vertices here. That is also square and a circle. Draw diameters parallel to the sides of square. This is a side. Then parallel to the side diameter is here and this side parallel to the diameter is here also. That is over of the square. And draw a polygon joining the end points of those diameters and the vertices of square. Square and the vertices and diameter join ചെയ്യുന്നു. There you get a polygon like here. You get a polygon. You get a polygon like here. That polygon you can see here. This is a polygon. Then you want to prove this polygon is a regular octagon. We want to prove this polygon is regular. Octagon is octagon. There is no problem for octagon. That is 8 side is there. 1, 2, 3, 4, 5, 6, 7, 8. 8 side. Therefore it is octagon. And you want to prove it is regular. For regular, we want to prove both two conditions. What? Angles are equal and sides are equal. We want to prove each sides are equal. Each sides, 8 sides are equal. Then only we can see sides are equal. And additionally, we want to prove angles are equal. And if sides are equal and angles are equal, if both conditions are satisfied, we can see it is regular. Then only we can say it is a regular octagon. For that, you want to note this length is A and this length is also A. That is, this square is of length side 2a. That is, this length is a and this length is a. Then this length is a, this length is a, that implies this length is also a. And this total length is the radius. This total length is what? The radius, and it is denoted by r. Then consider this side, if it is denoted as AB. This length is denoted AB. For this small triangle, we can see a small triangle, that is a right triangle. That is a right triangle, and therefore this hypotenuse AB is equal to this small side A, that is square. AB square is equal to this side is A square, and this side is what? Only this small length. The total length R, small length A, therefore plus we can see that is R minus A. This length is what? R minus A. This is full length R up to this A, therefore this length is R, that is R minus A square. And AB is the length A square plus R minus A whole square, Pythagorean or right triangle. Therefore AB, you can see what? AB is the root of A square plus R minus A whole square. Similarly, we can see BC is also like that. Here A, and here R minus A. Here A and here R minus A. Therefore, BC is also same triangle. These two triangles we can see same. What is the reason? These two triangles are same. What is the reason? Same side A and same. This is R minus A and this is R minus A. And this angle is same. This angle is same. Therefore, these two triangles are equal. Therefore, you can see AB and BC are not different. BC is equal to what? AB. And this is CD. Then CD is same argument. We can see CD is also same. AB. Therefore, all length are same. You can see all the length of this octagon are same. Now we want to prove angles are same. Now we want to prove if it is regular, the angle should be a constant. That is, we can see octagon. What is total angle? That is n minus 2 into 180. That is, total angle is n minus 2 into 180. That is an equation. And divided by n is each angle. You can see for this angle, you want to calculate what? N minus 2 into 180 by n. What is n here? Octagon, 8. 8 minus 2 is equal to what? 6 into what? 180. 6 into 180 divided by n is 8. 8 minus 2 is 6 divided by 8. Then 6 into 180 divided by 8, you can see it is 135. Therefore, you want to prove each angle should be 135. Then only we can say it is a regular octagon. For that, we want to prove this angle is 135. We want to draw a line here. Therefore, you can see these two angles. No, these two sides are equal. This is a radius. This is also radius. This small triangle, you can see. These two are radius. Therefore, these two angles are equal. This angle and this small angles are equal. What is this sum? What is sum of these two angles? What is the sum of these two angles? You can see this angle is 45. This total is 90. Therefore, this angle is what? 45. This total is 90. Therefore, this angle is what? 45. In a triangle, this is 45. Therefore, sum of these two angles is what? 180 minus 45. 180 minus 45 is what? 135. That is, these two angles sum is 135. And these angles and these angles are equal. This angle and this angle is equal. Therefore, this sum is 135. This sum is 135 means these two angles are equal. Also, these two angles are equal. Therefore, this sum is 135. Therefore, this angle represent the angle of this octagon. Therefore, angle of the octagon is 135. Therefore, all angles of this octagon is 135. Therefore, it is a regular octagon. You can see that.